Welcome to our mini-series dedicated to Onteon. Today we'll cover machine learning model deployments to production using the platform on ARM devices. What do we have for today's demonstration? First of all, we have two models already trained, one using k-nearest neighbors and second using PyTorch. Both models are exported to files. Simple Python application using Flask framework is used to expose these models as services. Usually for production use, when we have many applications and many devices, we would use some kind of orchestration platform. In this case, for the deployment and management, we will use Onteon with its node manager installed on ARM device. Firstly, a few words about Onteon. It's a platform that supports development, deployment, and management of applications in distributed architectures. It's a software stack that includes everything you need to run applications in production: provisioning, orchestration, runtime, monitoring, services communication, load balancing, and log management. All capabilities are part of the Onteon. It means it's complete toolset most companies would need for production environments. Most of existing platforms works with containerized applications only. While using containers is convenient, it also has its drawbacks. It adds another abstraction layer to the environment. And it consumes additional memory and CPU, which is a limited resource on IoT or edge devices. Onteon orchestrates containerized application, but it can also manage non-containerized applications the same way, and it can be a big benefit for your solutions. So why to use Onteon for deployment and management of applications in IoT world? To save on resources, to give better performance for applications, to provide true business continuity, and to save on other costs, as Onteon is a complete and easy to manage platform. Now, let's start the demo. Here we have application version 1 with k-nearest neighbors algorithm using NumPy library. Model is trained and saved to the file being part of tar archive. It is exposed to external world via API. Second application, version 2, uses model created with PyTorch. It is also saved to the file. We have also script used to test iris classification. This daemon is running on Onteon Node Manager installed on Raspberry Pi with ARM processor. Onteon uses tar files for applications and its configuration files. Here we have an example application. At first, let's untar file to see application configuration file. Here we have a configuration file of our application. As you can see, there's a few basic information such as a name of application, version, prototype, which in this example is native, because this application is not containerized. In the start section, you can define command that will start application. Looks pretty standard. Basic command to start an application. As you can see, in Onteon we can make use of placeholders. First placeholder is used to specify the path of Python application. Second one is used for ports. Onteon will automatically choose port for your application. If your application needs more ports, you can simply add other placeholders like ont_port, _2, 3, etc. The last one in the example is placeholder for application logs. So Onteon simply runs any application. You don't have to modify it. As this demo is dedicated to machine learning deployment, we don't explain here other configuration variables. If you want to learn more about Onteon application configuration file, please watch our other videos or look at documentation. Let's upload our example applications. There are two applications. First, with version 1.0.0 uses k-nearest neighbors, and the second one with versions 2.0.0 uses PyTorch. As you can see, applications are created. Now let's create application instances manually. First, we need ID of destination node. Now we can create instances on destination node. This is our Raspberry Pi device. Now, when application instances are created, we can start them. As you can see, both applications are running. Now we can send requests to a specific version of application by using by name and version URL pattern. Here we are sending request to application version 1. And we can see the result. And here we are sending request to application version 2 with different result. The results are different because we use two versions of applications based on different models. Now let's stop and delete application instances. Most of the time, you want to distribute your applications manually. For this, it's better to create a distribution that automatically distributes your application instances. Let's see distribution file for an example application. Distribution file contains very important information. Firstly, what application you want to distribute. You can use application ID or name and version. Secondly, number of instances you want to create. And finally, scripts that decides how to distribute instances. In our case, we will use default Onteon scripts. Let's create distribution. Now you can see how distribution automatically creates and stores instances. Let's check if application is really working. This time we'll use URL with by name pattern that automatically chooses the version. As you can see, Onteon redirected our request to one of the instances. Now we will upgrade our application to version 2. To do that, we need ID of old application and ID of new application. Let's see how new versions of applications are automatically created, replacing the old ones. Let's check if our application works and what results gives. Notice that we don't need to change the URL for new version of application. Now we will scale our application. You need to get the idea of distribution, and then you can set the number of instances you want. Now you can see how distribution creates new application instance. Here is an example with the same applications but containerized. Let's see application configuration file. It's pretty much the same configuration as the native application configuration. The only difference is that instead of specifying start command, you need to specify image that will be pulled and started. Also, we need to configure ports. Let's upload applications. Now let's create instances. Now when application instances are created, we can start them. As you can see, Onteon started container from proper image, then forwarded inner port to external, automatically selected port. Let's start the second application. As you can see, applications are ready and we can send some requests to them. Like in the previous example without containers, here we got different classification result based on the method used. What have we demonstrated? We showed how to deploy applications using machine learning models. We showed how to do this natively or how to do this via containers. We also demonstrated several Onteon capabilities. For more information, please visit our website or contact us directly.